Hi, I'm Ruben Kuiper and I'll be presenting SPaR.txt, a cheap shallow parsing approach for regulatory text. The aim of our work is to identify possibly discontiguous spans of tokens that form a single unit of information. So an example in the sentence above here is should be entered, where it's not a contiguous span of tokens. We use a relatively simple annotation scheme in comparison to example given dependency parsing. We only have 4 span types, and we have a modified bio-tagging scheme where we do not take into account outside tags. So we actually tag every token with the aim of leveraging interdependencies. And the learning task is set up in a way that it should easily transfer knowledge and patterns from pre-trained embeddings. And so the result is a cheap method in terms of annotation and how much training data is needed that can support the collection of domain lexicon. We evaluate our system on how well it predicts object spans found in the Scottish building regulations, and we find that the system identifies 90% of the defined terms found in this specific defined term section, and in comparison to human judgment, about 70% of the predicted objects is an exact match with what a human would annotate. And you can find the code and data for our system on GitHub. In this presentation, I'll talk a bit about the background, which is automated compliance checking in the construction domain, so that I can kind of like define the scope of this work more specifically. And then I'll talk a little bit about processing discontiguous multi-word expressions, annotation, model training, and evaluation. So automated compliance checking is about automatically checking whether a building information model complies with the relevant building regulations. And so these building information models capture all sorts of information about buildings, like distances, fire safety measures, everything you can think of, in order to show that the building actually complies with the regulations before it's allowed to be built. But it also should contain that type of information during maintenance and even for destruction of a building. And so regulatory documents are an important part of the legal framework for all of this construction work. And non-compliance with building regulations has actually been linked to fatal accidents as well. Think of the tower in Miami or Grenfell Tower in London. Compliance checking by hand is actually a quite complicated task and very time-consuming because the regulations are distributed over hundreds of manually curated documents. And also the criteria can be ambiguous and sometimes even conflicting. Criteria often also refer to specific clauses or even entire sections or other documents, and the regulations change all the time. So automation can really reduce the difficulty, time, costs, and number of human errors, etc. However, automation is not that straightforward. So if you look at kind of what is required, then on the one hand you have the regulation text, and on the other hand you have these BIM models, and the idea is that you would extract information from the regulations and classify them into certain symbols that have to match the symbols in these BIM models, so that you have some sort of like shared representation that captures the rules and a representation for these BIM models that can be validated using that shared representation. So the research in this field is kind of split between two types of work. On the one hand, you have this reasoning over a hard-coded rule-based system to check whether some small part of a BIM model actually complies with the rules in the rule-based system. And on the other hand, you have semantic parsing, which focuses on natural language processing to identify these rules in the regulation text. Now, the conversion of text to rules is usually done in a kind of like rule-based manner. And the machine learning-based studies focus more on subtasks, such as named entity recognition and relation classification. And a lot of this work to reduce complexity omits working with qualitative criteria, tables and diagrams, and also exceptions, conjunctions, lists, references to other clauses, etc. And so really what happens is that you have these quantitative criteria only that are being processed, and then if you have a rule-based system that could somehow identify what kind of rule or could convert the sentence to somewhat of a rule, then you still have to identify these symbols in that rule or in the text. So span, floor, etc. And so the need is for a domain lexicon to actually like ground these symbols and relations. And if you look at orthogonal research, then there is some work on sort of idiosyncratic markup schemes that help human annotators identify regulations that are relevant to whatever work they are checking on compliance. And there's also systems that try to break up more complicated sentences into simpler clauses. And these types of works, or this type of direction of work, also finds that the performance of these systems decreases when they're handling domain-specific multi-word expressions. And so the need really is for a domain lexicon that can also handle multi-word expressions for automated compliance checking. Now, working with multi-word expressions is a key issue in natural language processing. And so we follow a simplified definition, a kind of simple definition, where multi-word expressions are possibly discontiguous word combinations where words are separated by white spaces or punctuation in text. Multi-word expressions are often annotated as part of a tree bank, but here we are not working with trees. And so we rely on this alternative kind of like modified biotagging scheme. And specifically, we also omit this outside tag. So we end up with 4 tag types, 4 tags and 4 types. And for functional and Discord spans, we don't really find any discontiguous spans. So actually, we end up with 12 classes. As our data, we scrape the Scottish building standards because a lot of the building standards are actually not in a machine processable format or behind a paywall. And specifically, the Scottish building standards are machine processable and published under the Crown copyright. And so our assumptions during annotation or before annotation are that these building regulations contain few to no idiomatic expressions, which is very important with working with multi-word expressions. And we also expect little variation in service forms. So actually, that should be reflected in a relatively small vocabulary. So there's little use of, alternative ways of expressing a concept because that would be less clear. That's the kind of intuition behind this. And if you look on the right-hand side, then in comparison to the Brown corpus, a much more heterogeneous corpus, then indeed the Scottish standards have a lot smaller vocabulary, let's say. We annotated 200 randomly selected sentences, and a second domain expert annotated 140 of these, and the inter-annotator agreement was found to be 0.79, which is pretty good. For the specific annotation guidelines, I will refer to the paper because there's not that much time during the presentation. And for the model, we use a straightforward BILSTM with a conditional random field on top. The thing we do add is this relative positional self-attention, which provides some information about preceding and tags that follow, basically. And that does improve performance a bit. We actually thought that span bird embeddings would provide the best performance for us, but actually regular bird embeddings perform better. So that was a bit counterintuitive, but that's possibly because SPAN-BERT only masks contiguous spans and also a fixed size of spans, whereas we are working with like different sizes and discontiguous spans as well. More generally, there's an issue, of course, with how small the data set is and the imbalance of tag types. We evaluate our system extrinsically on identifying object spans. So the first thing we do is we compare how many of the defined terms from the defined term section we actually find in the text. And that's about 90%. Some of the terms that we miss include common modifying words, for example, average and average flush. So that will be broken up by the system into, average being a functional span and flush being an object span by itself. And also there are several unseen syntactic patterns, such as factory with class 1 in parentheses, that the system hasn't seen during training. We also perform post hoc human judgment, where we initially predict tags for all the sentences in the Scottish regulation corpus. So we find about 16,000 unique potential object spans, and we randomly select 165 of these, excluding the defined terms. And then for each of these objects, we select a sentence in which the object occurs. And then we have a human annotate whether they agree with whether this object is actually exactly how it should be annotated. So in the bottom here, for example, you have mechanical input air ventilation systems, which is considered to be a single unit of information by the human judge. So final thoughts, the performance of our system is actually quite impressive with regards to the amount of training data, which suggests that the task indeed transfers knowledge and patterns from pre-trained embeddings. And the current model already supports or enables the manual assembly of a domain lexicon, and also it provides a way to do some iterative training and re-annotation specifically to identify sentences where prediction errors are made. So that brings us to the questions.